Hi everyone, welcome to another GCSE Chemistry session. Just bear with me and I will share the screen with you. Here we go. So this is going to be a revision session. What we're going to revise is all the little topics that we've been doing over the last 11 weeks or so. Okay, so since the beginning of school closure. And this session is designed where you can kind of pick up and leave bits wherever you want to. So if we are revising something and you think, I know that, yep, totally got that, my notes are right here, I don't need this, then feel free to just skip through the video and just use the bits that you need. Okay, so it's meant to be just really useful for you. You can just pick the bits that you need. If you feel like you just want to go over it all again, then that's absolutely fine. You're very welcome to just watch it all, pause and complete what you need to. Okay, so make sure you've got a pen and a piece of paper or your notepad with you. The learning question, how can I revise chemistry? And there's a very simple do it now there for you. So remember the three subatomic particles, protons, neutrons and electrons. So what are their relative charges and what are their relative masses? And there's a very simple diagram of an atom there, and I'd like you to label which one's proton, which one's a neutron and which one's an electron. Okay, so pause the video and have a go at that now. And remember, if you don't need to do this part, if you remember it totally, you can just listen to the answers to double check if you want to, or you can just skip right past it. Okay, well done. So neutrons are here in the middle, and protons are here in the middle, and the electrons are around the outside of the atom. And the relative charge of a proton is +1. So actually this diagram here is not correct because it's actually, this should be the proton, the +1 part. So I got an image from Google and it's actually wrong. So we can correct that. So this here is proton. The neutron has no charge at all. That's why it has the name neutron. Neutron, neutral. Yeah, means nothing. So no charge. And electron has a charge of -1. And the relative masses, protons and neutrons have a mass of 1. And an electron either has a mass of 0 because it's so tiny that we don't really count it. Or you can just say negligible. Yeah, so it doesn't really have a mass that's worth worrying about anyway. Okay, so looking then again at an atom, so the nucleus is in the middle of the atom and that's what holds the protons and the neutrons, so they're kept here in the nucleus as you can see in that diagram there. So all the mass is inside the nucleus in the middle of the atom, and the electrons spin around the outside in what we call shells. Okay, electron shells. So what I'd like you to do is try and remember how many electrons can the first shell hold and how many can the second and the third shells hold. Okay, so pause the video. You can have a go if you want at sketching out this little diagram of an atom and drawing X's to show how many electrons can be held in each shell. Well done. So the first shell can hold 2 electrons. It can't hold any more than 2, so up to 2. And the second and the third shell can hold 8. Okay, so well done if you remembered that. Okay, so what I've got here for you is a bit of revision about what the terms atomic number and atomic mass mean. Okay, so if you think you can do this already, then pause the video, have a go at sketching out this table and writing in the missing numbers. Okay, so pause now. If not, I'll go through a bit of an explanation with you. All right, so the atomic number means the number of protons inside the nucleus of that atom. And each element has got a different atomic number. If the atomic number was to change, then it would become a different element. Okay, so each element has a specific atomic number. And as you go through the periodic table, that atomic number increases by 1 each time. Okay, so that's atomic number. Mass number is the number of protons and neutrons inside the nucleus, so inside the centre of the atom. So now that I've gone through that, now you can pause the video and have a go at filling in the blanks in this table. Okay, so for carbon, because it has an atomic number of 6, so I know it has 6 protons, and it already told me that the number of neutrons was 6, I know that the mass number is 12, because 6 add 6 is 12, so that's the mass number. Okay, the number of electrons, that's really nice and easy to work out, because it's always the same as the number of protons. The reason for that is, if they were different, then the atom wouldn't be balanced, because it would have a different number of positive charges to negative charges. So atoms always like to be balanced. Okay, so that's 6 as well. And then down here for the potassium, the number of protons is 19. And how could I tell that? Well done, because it's the same as the number of electrons. Remember, they like to be balanced. So I've worked out the number of protons. That means I can work out the atomic number, because if there are 19 protons, then I know that the atomic number is 19, because the atomic number is the number of protons. There we go, 19. And the mass number, remember, is the number of protons and the number of neutrons. So I would just add this number here to this number here. That would give me 39. Okay, hope all of you managed to work that out all right. If you need to go back and just go over the explanation that I gave, then you can do that. Or if you need to look it up on BBC Bite Size, you can do that as well. So an isotope is an atom of an element with a normal number of protons and electrons. Remember, if the proton number changes, the whole element would change, so that never changes. But an isotope has a different number of neutrons. And that's quite a common exam question in GCSE papers, asking the definition of what an isotope is. So if you'd like to pause the video and just copy down that definition in your notes, that would be great. Well done. Now we're just going to go through a quick quiz. So it's just a little quiz on basic chemistry. So what you can do, write out the question number, write out the answer, and then we'll double check that you got it right. Okay, so what subatomic particles are found in the atom? Well done. Protons, neutrons, and electrons. If you need more time to answer these, then just pause the video to give yourself a little bit of time to jot them down. All right. How many protons are there in an atom with an atomic number of 54? Well done. Yep, 54. Atomic number is sometimes called proton number, because it's just literally the number of protons inside the atom, in the nucleus. How many neutrons are there in an atom with an atomic number of 12 and a mass number of 25? Well done, 13. And if you're not sure how we got to that, remember the mass number, so this 25, that's the protons and the neutrons. So that's that mass number of 25. It's asking us how many neutrons. Okay, so we just need neutrons. We know that the protons is 12 because that's the atomic number and they've given that to us. So we need to take the whole number, take away 12, and that will give us just the number of neutrons. So that'll be 13, because 25 take away 12 is 13. Okay, isotopes of an element have a different number of something, but the same number of something. So fill in the blanks there. Well done. So a different number of neutrons, same number of protons. What's the vertical column in the modern periodic table called? So that's what the columns going down. What are they called in the periodic table? You've got eight main ones of them, haven't you? They are called groups. And the horizontal rows, so if you go across the periodic table, what are they called? They are called periods. So carbon is in group 4 of the periodic table. How many electrons are in its outer shell? Hopefully you will get this, because we didn't look at this too long ago, did we? Fab, 4 electrons, okay, because it's in group 4. So 4 electrons, that's 4 electrons in its outer shell. Okay, chlorine's atomic number is 17. Can you write out its electron configuration? So you need to, for this, you need to remember how many go in the first shell and then the second and the third. Well done. 2 in the first shell, 8 in the second shell, and 7 in that third shell, in that outer shell. So we also, for a bonus point, which group is chlorine in the periodic table? Well done if you guessed it. It's in group 7 because it's got 7 electrons in its outer shell. Okay, draw the electron configuration of oxygen. So draw me an atom of oxygen, and its atomic number is 8. Here we go. So 2 electrons in that first shell, and then 6 in the outer shell. As long as you've got 6 electrons, it doesn't really matter where you put them, but traditionally you would draw 2 pairs and then 2 separate ones. Okay, so just a little bit of revision of states of matter. So solids, liquids and gases. So I found just a very simple diagram of a solid, a liquid and a gas, and a little description. So one of them has particles that can move around, one of them has particles that can only vibrate, and one of them has particles that are in a regular structure. So I would like you to draw out the 3 states of matter, please, and just write a very simple description for them. Okay, and if you need to use BBC Bite Size or your old notes to do that, and that's great. Okay, so taking those states of matter, then we can look at state changes. So that is when a substance moves from one state to another. So what I would like you to do, please, is copy out this diagram and try and write in the labels of the state changes, please. Okay, so just pause and copy out that diagram and write in these labels. Excellent, well done. So now we're just going to stop for a moment and do a little mini quiz. Okay, so here are some hinged questions or a little mini quiz for you. So this will need you to pause the video because everybody will take it a different amount of time to complete these. So some people might only need 5 minutes, some people might need a little bit longer. Okay, so however long you need, don't panic, just pause the video now and we will go through them in a moment. Well done. So if you can use the mark scheme then to self-mark your answers. All right, so I won't go through them. You use that mark scheme there and you can mark your own answers. So ticking or crossing your own answers. Well done. Okay, so if you got more than 5, you're going to have a go at the gold task in the next slide. If you've got less than 5, then you're going to have a go at the silver task in the next slide. Okay, here we go. So again, pausing the video and having a go at either the silver or the gold task. Brilliant, well done. Okay, so another thing that we looked at very briefly was pure substances and how a pure substance was different to a mixture. So I'm just going to run through some bits of revision now over the next couple of slides, and you take what you need. So if you need to pause the video and write down some notes, that's fine. So a pure substance has a fixed composition, so it can't be separated by any physical methods. Whereas a mixture has got elements or compounds in that are not chemically joined together. So you can use different methods to separate them, like filtration or, what am I looking for? What's the word? Filtration or evaporation, crystallization, that sort of thing. All right. Okay, dissolving is when a solid is mixed into a liquid. Okay, so the solute is the substance that you are dissolving. So say you are dissolving some salt into water to make salty water. The salt there would be the solute. The solvent would be the liquid that the solute is going to dissolve in. So say I had salt and water. Salt is my solute, water is my solvent. And what you get when you mix them both together and stir is a solution. All right, so that's when the solute has dissolved in the solvent, you have a solution. So my solution would be salty water or salt water. Okay, they're tricky words to get your head around, but they're very important to know the meaning of. Okay, so remember, we looked at some separation techniques, didn't we? And the first one that we looked at was filtration. So that's when I'm separating an insoluble solid from a liquid. So liquids can pass through the filter paper. The insoluble matter is trapped in the filter paper. So say I was separating out sand in water. I would pour the sandy water into the filter paper in the funnel. The water would be able to travel through the filter paper, but that insoluble sand would be trapped here inside the filter paper. All right. What I'd like you to do is pause the video and just have a go at labelling that equipment. Well done. So we have got the beaker that would have the salty water in. We'd have a conical flask here. That's almost like triangle shaped flask. We'd have filter paper that we folded and put inside the funnel. Okay, so we've got the funnel here that we sit inside the conical flask. Well done. Okay, remember the other separation technique that I couldn't think of the name of it just a moment ago is crystallization. So that's where you evaporate a solution so that you just leave behind the solute. So if you imagine I'd made that salty water that I was talking about a moment ago, so I've got a beaker of salty water. Now I'd like to separate it back out again. What I can do is I can use crystallization. So first of all, if I wanted to, so this is sort of an optional step, I could filter it just to remove any solids, any undissolved solid that there might be. And then what I would do is I would put the solution, that salty water solution in an evaporating dish, put the evaporating dish on the top of a Bunsen burner and heat it. And that would evaporate off the water and leave me the salt crystals here at the end. Okay, the other separation technique that we looked at was paper chromatography. So remember, this is separating dissolved substances when they are mixed together. And ones that are more soluble will travel up the paper further. And remember, we used it to separate out different mixtures of different inks when we were looking at that method, didn't we? Okay. There are videos on YouTube of paper chromatography if you want to go back and have another look at the method of it. Okay, another technique, another lab technique that we looked at was distillation. So that's where you can separate a pure liquid from a mixture of liquids. So say I have a mixture of water and ethanol, I could separate them out by using distillation. Here they are separating out a solution of salty water. So the water would evaporate because it's being heated. It would travel through what we call, do you remember the term Liebig condenser? If you can remember that, that's great. If not, a condenser which has got cold water around it to help cool down that water vapor and condense it back into water. So like I said, that there's a Liebig condenser, or just the condenser. It's designed to cool that water vapor back down again so that it turns into pure liquid water. You've got a round bottom flask here, which your solution is in. Heat here, or you could put Bunsen burner. And this is where your cold water goes into your water jacket or your Liebig condenser. Okay, nearly there. Just a couple more things to revise that we've been through. You realise, you know, when you make a revision lesson like this, that we've been through loads. So that's why we're doing a revision lesson, and we're going to set a very short test for you, just so that, you know, you can realise how much you have learnt in the last many weeks. So the stages in making our water safe to drink. Now, if you can't remember this, I did a whole lesson on making safe drinking water. So you can just go back into YouTube, look through the chemistry videos and find that. Okay, so remember, water from the source, so it could be from a lake or a river, is put into a big sedimentation tank where all the large solids kind of float down to the bottom. Then it's put in a filtration tower where it filters through sand and gravel to remove, you know, lots of bits of debris. And then it's this part here where the writing's mission, that's the sterilisation tank, where chlorine or another steriliser is added to it just to kill any bacteria or microorganisms. And then it's stored in a drinking tower here. Okay, so that's the last part of revision that I have for you. Okay, if you want to, you can go back and look at any of the videos that I've made for chemistry again, because like I said, we are going to set a short test for you next week, just before the summer holidays, so that you can just feel really confident in what you've learned, really, and, you know, have something to put all this learning towards. Okay, but that's it from me now. Have a lovely week. Happy revising. So for chemistry this week, if you can just revise all the topics that we've learned, they will be on class charts for you if you can't remember them. And have a lovely week.